Okay, so in this video, I'm going to introduce you to how to read a pump curve. So when you are sizing a pump, what you need to have is the total dynamic head, and the flow rate required. Then using these two, you can go to a vendor, or you can pull up you can go to a vendor's website if the data sheets already uploaded there. So let's look at this curve. So that's a pump curve. So the first thing that I'll probably show you is that on the x-axis here you have your flow rate. So whether it's your cubic meters per hour, your liters per second, you have your flow rate. Then on this y-axis, on this vertical axis, you have got your head. Whether it's head in meters or feet, it doesn't really matter. So that's your head. Then the next thing that you have is you have what is called a pump curve. The pump curve. So in this case, our pump curve is this. So this is a curve that is provided by the manufacturer. So in some other pumps, you might see maybe 3 or 4 different pump curves. So in that case, those will be different sizes of impellers, maybe for the same pump, but it can have maybe 2 or 3 different impellers, and each impeller, it will have its own profile of the pump curve. So this line is showing the pump curve. It's provided by the manufacturer. It's based on how they have tested their pump to say that, okay, when there is zero flow, what is the maximum head? When the flow is 1, what's the head? Is 2, what's the head? And so forth. Then using that, they plot this pump curve. So it's the manufacturer of the pump that supplies this pump curve. That's the first thing. Then the next thing that you will see here is we have got the efficiency curve. So on this one, it is shown by this dotted line. That's our efficiency curve. So the efficiency is the highest at this point. So at this point, that's peak efficiency. At this point, that's peak efficiency. So at this peak efficient point, if you draw a vertical line down, so at the point where the vertical line touches your pump curve, this is called the best efficiency point. So the point where if you draw a vertical line from the peak efficiency to the point where it touches the pump curve, that point is the best efficiency point, meaning at that point, for this pump curve or for this impeller type, this is where it performs the best. So it is at this point. Okay, now, so we have the pump curve provided by the manufacturer. You have efficiency curve, obviously it's provided there by the manufacturer as well. So you've got your best efficient point. Now, so at what point now do you start to put your things there? So what you now need to do is that then there is the other thing, or the next thing, which is called the system curve. So the system curve, this is a curve that will be derived from what your system wants to achieve. So in most cases, when people are sizing the pump, they'll simply say, I want a pump with a head of, let's say, 100 cubes an hour. A head of 100 meters and flow rate of maybe 200 cubic meters an hour. So they can just come here and then try to find those values. But another way you can do it, or maybe a better way of doing it, is to have the system curve. The system curve. So the system curve, this is a quadratic equation which has got a constant, and this constant is the static head. So this blue curve here, that's the system head. So how do you determine the system head. So the system head, you determine it by using the total dynamic head. So total dynamic head, what it is essentially is equals to the static head, H stat, plus plus the head losses due to friction, HF, plus the head loss due to minor losses, HM. Okay, HLM. So these are the three things that make up the total dynamic head. So you just plot your system curve on this graph. So the point where your system curve intersects with the pump curve, that point is called the duty point. That's where your pump will operate at. Because we are simply saying the system curve, this is the work that the pump should do in order to pump the water. So the point where the system curve intersects with the pump curve, that point is the duty point. So that's the duty point. Duty point. This is where your pump should be operating from. So at that duty point, if you go down, you can get the flow rate. Then if you can go to the left side, you can get your head at the duty point. So another easy way is, if you know your flow rate and your head, you can simply go to the flow rate, you draw a vertical line up, and where that line touches this pump curve, you then come to this side. That's another simple way of getting your duty point, where you know that, okay, my flow rate is 200. You just go to 200, you draw a vertical line where it touches the curve, you go this side, and you have your head. So that's another way also to get your duty point. Now the last thing that I want to talk about is that we've mentioned the best efficiency point, where we say that that's the point where the pump is operating, where this pump operates at the best efficiency. So ideally, you would want your duty point, which is this point in this case, to be close enough to your best efficiency point, and it should be plus or minus 20% from the best efficiency point, because what it means is that you want your duty point to be close enough to the point where the pump has the highest efficiency. That's what this means. So as you are selecting your pump, make sure that your duty point is close enough to your best efficiency point, because if it is far away, it means the pump that you've selected is not efficient, and this might result maybe in more OPEX cost, and also your pump might not be able to last as it is supposed to. So you need to be aware of this. If you've got any questions regarding the pump curves, how to read these graphs, you can let me know, send questions, or you can drop comments. You can get in touch with me, and we can probably help you to get a better understanding of this. See you in the next.